The purpose of this video is to provide a little bit more assistance with transmutation problems. Hopefully, after I work through these two examples, you feel more confident solving these problems. What I'm going to do is try to get you to eliminate all the distraction, all the noise. This is the first thing we want to do when we look at this problem with radium, which undergoes alpha particle decay. Alpha particle, remember, is the same as the helium nucleus. We want the amount of protons on each side to be the same. So if we remove all the noise and kind of think of this as a math equation, I have 88 protons on the left side of my equation. I need an equality. I need 88 protons on the right side. I already have 2 with the alpha particle, so that means I need 86 more protons. So now I have an equality, eliminating all the noise and distraction of everything else, where I have 88 protons on the left side of the reaction, and I have 88 protons on the right side of the reaction. Now I need to know what element has 86 protons. To do that, I need to look at my periodic table. If I look up 86 for the atomic number, that's radon with the symbol of Rn. So then I can put in my symbol, radon, Rn. I'm going to follow the same procedure, try to get rid of all the noise using the mass numbers. So I know radium had a mass number of 223. So on the right side of the equation, I also need a mass number of 223. An alpha particle gives me a mass number of 4. So what plus 4 gives me 223? Well, that would be 219. 219 plus 4 equals 223. So now the mass number on the left side of the equation and the right side of the equation are the same. So if you just get rid of the noise, if you only concentrate on the atomic numbers and the mass numbers, these problems may be a little bit easier for you to solve. Let's look at this beta decay problem involving phosphorus. So phosphorus undergoes beta decay. Let's get rid of all the noise and focus on the atomic numbers. I have 15 protons on the left side of the equation. The beta particle has a -1 charge. It has -1 protons, if you will. I have to have an equality. So what plus -1 gets me 15? Well, that would be 16. 16 plus a -1 is 15. So now I have the same amount of positive charge on both sides of the equation. I can use my periodic table and look up which element has an atomic number of 16. I can see that's sulfur. So I know my symbol is S for sulfur. Now I can balance out the mass numbers. Phosphorus had a mass number of 32. Well, we have to have the same amount of mass on the right side of the equation. Well, beta particles don't have any mass. So what plus 0 gives me 32? Well, that's 32. So I know my sulfur had to have a mass number of 32. Okay, if I bring back all the noise, you can see I have a charge of 15 on the left, and on the right side of the equation, 16 plus a -1, that's a 15. I have a mass of 32 on the left side of the equation. On the right side, 32 plus 0, I got a mass of 32. I was able to determine the symbols by looking up the atomic numbers on the periodic table. I hope that helps you with transmutation problems. We'll keep practicing.